So, homework. Are there any questions you would like me to work out on the board in front of the class? Joe says yes. Joe gets first choice because he is our resident math person. Joe, what question would you like to see me work out from the homework? 1525B. Okay, here we go. Chapter 15, 25B. Okay. Well, let's talk about it.
Danny, how many questions have you done?
I'm like 2 into chapter 15. Or like 4 into chapter 4.
What do we say? We listen and we don't judge. Yes.
You know what? Okay.
Well, we know you do. So,
Diarrhea. You can go back on the Disney.
all right, chapter 15. Oh, is this the hopper? I call this the hopper. The hopper. Chapter 15. You'll see in a second. 15. I gotta get to the right thing. Okay. Calculate the pH of the following solutions. So we're on 25B. So this is chapter 15, 25B. So I have, this is B, I have a 0.100 molar of NaC3H5O2. Yes?
Yes. Yeah, I see that.
So the first question on this one is that an acid or a base? What? So first thing I would do is I would write my reaction, right? So my reaction for a base, so here is my R. What do I usually add on my, am I going to write this whole thing? Do I care about this whole thing?
No.
What do I only care about? I only care about the C3H5O2 minus, right? Plus, what do I add to that? Water is in equilibrium with HC3H5O2 plus OH minus. Yes? It's a spectator, right? I don't really care about the spectator. This is the ion that's actually doing something. Initial. They tell me that I've got 0.100 molar. Agreed? Yes? Yeah. Water's not part of this. Yes? Yeah. So, it's going to be 0 and 0 because none of this has dissociated. This is a weak base, correct? Yes. Change is going to be minus what? X. Minus X. Not part of it. Plus X, plus X. Equilibrium is going to be 0.1 minus X, not part of it, X and X. On this one, do they give me a Ka? No. So,
Would you have to find it?
It's in the back of the book.
I think you have to look up the Ka.
Yeah, it's
But on this one, I'm trying to think if it's a KB, it's KW over KA. I think you have to look up the Ka in order to do this.
That's what I had to do, because it doesn't have it in.
It says, the acid dissociation constant of propionic acid K equals 1.3 times 10 to the negative.
That's what I had.
1.3 times 10 to the negative fifth.
That's what Google AI says, which is very tough.
Okay. So, I don't need Ka though. I need what? I need Kb, right? So I know that Ka is 1.3 times 10 negative fifth. And I know that Ka times Kb equals Kw,
Oh, right.
right? So Kb is going to equal Ka divided by Kw. So Kb is going to equal 1.3 times 10 to the negative fifth divided by what? 1 times 10 to the negative 14th. Yes? Because Kw is always 1 times 10 to the negative 14th.
So that's a constant.
It's a constant.
Okay.
Yes, which I believe is that up there? Yes.
Yeah, okay.
Kw is up there. So you end up getting Kb equals 7.7 times 10 to the negative 10th. So there's your Kb. So set up your little K expression. Kb, which equals 7.7 times 10 to the negative 10th, equals x squared over 0.1. Because where's that minus x going? To 0. Because it's a small k. Yes?
If you like know that, do you have to make the table? Like, or can you just do like
No.
the number and then
You could literally just go straight, like I will understand where this came from, right?
Yeah.
If you know it's a small k, this is the shortcut. I showed you that in the notes.
Okay.
You go straight to this. As long as you have this work,
So we don't have to make a nice table.
no,
Okay.
you don't have to show the ice table. As long as you show the work to say
As long as we
it's
know
x.
the-
If you write the k expression, yes.
Okay.
So solve for x. X ends up being, I got 8.8 times 10 to the negative 6 molar. But that is equal to my concentration of OH minus, and it asks for the pH. So I'm going to take a p of that. So the negative log of 8.8 times 10 to the negative 6 equals 5.06. So I'm going to do 14 minus 5.06, and you get 8.94. You get 8.94 for your pH.
Did you first start recording?
What?
Did you remember?
I sure did. Also, I have printed you guys one more tool. I didn't make this, I found this. Okay, it's in color. So there's a calculating pH flow chart. All right. And then there's also the acid-base reactions and buffers, just kind of like general information of what to do. I think this is one of the nicest things I've ever found. And it had to be in color.
Nicer than like your mom, your like wife's wedding ring. Like
No.
equivalent to that.
But I did stare at my wife's wedding ring for like a week. Like I would go into the store every day. I would just like stare at it. I mean, it's a big purchase.
That's really cute.
And then eventually, like the guy's name was Jay. He's like, "Are you gonna buy it or not?" I was like, "Yeah." Can you get one, Ava?
Yeah.
Okay.
So I'm fine with it.
Yeah. So it was a good choice.
I say we get this.
Princess cut. What's that? No, you cannot use this on the test. But this is good. This is a good thing just to review and keep. And I put it in color. So it is beautiful. So when you look at this, it kind of like works you through of like what to do for pH, Henderson Hasselbalch, all the stuff. Yes.
What would happen if you had like something tattooed on you, like for a test?
You'd have to cover it up.
But is that like if like
If you got a tattoo,
Avogadro's number was tattooed on my arm?
that'd be fine because that's on the equation sheet.
Well, what if something not on the equation sheet then?
Then you'd have to cover it up.
Really?
What if they
Oh,
don't really
Danny.
have it though?
Danny?
Get the concealer.
Then if you get a full sleeve.
I mean,
You're like,
I can't cover my hands.
that was sick. Like,
what?
you would then make wear gloves.
I think you'd have to wear a glove.
That's
Yeah.
so crazy.
Like Michael Jackson, taking the test. Yes. Joe, you feeling good about that one now? Better? Okay. Next one.
Next, let's just keep going on the technology.
Wait, what was this?
This was
Wait, I think
What
it
was
was
the
one.
one?
I want to know actual questions. I don't want to just like keep going in order. I want to know if like there's one you wanted to see. Audrey.
I just have a general question about, because this came up earlier in the problems. Are
Okay.
you able to have a negative pH?
Yes.
Okay.
Wait, what?
Occasionally you can have a negative pH.
We actually
I know
have
it's pH only went up to 14.
It goes from 0 to 14.
Then how are there 15s?
I mean, it's possible to go above or below. Because think about it. It's just the concentration of H+.
Is that just that's
Um,
what the normal range is?
Yeah. Are you gonna see that on the AP test? No.
So you could have like, could you have like a 20 gauge or that?
You could, but like,
That'd be,
But like you're not gonna.
yeah, you're not going to.
Okay.
Can you do 90?
90 on chapter 14 or 15?
The
I guess 14.
chapter's 14.
Okay, sure. Let's do it. Chapter 14, number 90. Chapter 14, number 90. We're flipping all over the place. I like this. What's that?
598.
Okay, thank you. Page 598. 598. Thank you so much. Number 90.
Wait, oh shoot.
Okay, number 90. Oh, we got a three-parter.
Yeah, this one took me a good minute.
Letter A. Calculate concentration of OH, POH, and pH for each of the following. Letter A. I have 0.00040 molar of CaOH2. So I've got the molar of that. The first thing I have to do is figure out what is the concentration. First thing I would do is I would write a little dissociation equation. So I would say that CaOH parentheses 2 goes into Ca plus 2 OH minus. Agreed? You guys with me so far? So that means I have to take my 0.00040 molar and multiply it by what number? By 2 times 2, which gives you 8.0 times 10 to the negative fourth molar OH minus. So that's part 1.
Yes.
Does that make sense what I just did?
Yeah, that's okay.
Because if I have this, right, it'd be this times 2 for the concentration of OH.
Yeah.
Now I need to get the POH, so I'm going to take a P. So the negative log of 8.0 times 10 to the negative fourth equals, I had 3.10 for my POH, which means my pH has to be what? 10.9? So pH equals 10.9. So that's A. Letter B. I have 25 grams of KOH. So what do I have to do to grams? Convert it to moles. So KOH, what do they tell me? Oh, per liter. So I have 25 grams over 1 liter. So this is going to come out as molarity. So I'm going to use my molar mass, which is 56.11 grams of KOH in 1 mole of KOH. Agreed? So that equals 0.45 molar KOH. Right? Is this 1-to-1? 1.45 K to 0.45 OH. It's 1-to-1. So that means my concentration of OH equals what? 0.45 molar. Yes? Take a P. So the negative log of 0.45. I got, what'd you get, Haley? I had 0.35, which is my POH. So my pH is 13.65? 13.65. So that's B. And then C is pretty similar to that. C is essentially the same thing, just with a different number, different mass. Do I need to do that, or are we okay with that? Okay. Cool. That was number 90. Next one.
We do 89.
89, yes. Can I flip my page?
Yes.
Guys, we're making it. Like, the next chapter is easier than this. So,
Like, honestly, I'm
Electrochem.
scared for the test.
You shouldn't be.
I'm feeling decently confident.
Yeah, I feel like I gotta back down my like warning about the chapter because I feel like
Yeah, no, this is.
But no, it's a lot of culture, and you make us feel a lot more scared than when we get over. Like, oh, this isn't that bad.
yeah, but I don't want to make you feel scared. Like I just want to properly prepare you.
Oh yeah, I've got this. I'm done. Make them feel less
It's
scared.
like a confidence boost.
Yeah, it's like, oh, this is really scary. I know how to do this.
89 is similar to 90, right? So for 89, I have, okay, let's do A. 0.10 molar NaOH. NaOH is a what? Strong base, which means all of it is going to go to the base, correct? So that means that I have 0.10 molar OH, right? So I'm going to take a negative log. So negative log of 0.10 is what? 1, right? So that is my POH. So the pH equals 13. So that's A. B. On B, I have 1.0 times 10 to the negative 10th molar OH minus. I can take that all, right? Yes? Because it's a strong base. Yes?
Yes.
So, take a negative log. The negative log of that equals 10 for my POH. So pH for that equals 4. Right? What's a strong acid or a strong base? You just go boom, straight to it. You gotta ice it.
That's what you.
If it's not, you gotta ice it. Look at the flow chart, right?
Okay.
If it's not a strong acid or a strong base, you're gonna have to ice it.
Wait,
Is
Question,
And the negative 10.
the negative log of that is 10.
oh, okay.
And then the last one, how do you know if it's strong base or strong acid? Strong bases are alkali, metal, hydroxides. NaOH, KOH, LiOH, all right? And then everything else is a weak base. And then acids, so I ate no clean clothes. So I brought. I didn't ate. I ate. C, 2 molar OH minus, right? Which means I've got 2 molar. So the negative log of 2 is what? What? Anybody get that? Negative? Negative 0.3. Anybody else get that? No one finished it. Negative what? 0.3, which is my POH. So that means my pH is what? 14 point what? What? Yeah, 14.7. So my pH is 14.7. Sulfuric, iotic,
it's a negative.
nitric.
That's why it's because you subtract it.
I think it'd be, would it be 14.3? Yeah.
So I was definitely overthinking this. This is kind of easy. It's just
Yeah, you just overthought it. Sulfuric, iotic, bromic, nitric, hydrochloric, chloric. That's it, right? Not carbonic.
I thought this was the two C's were.
It's chloric and hydrochloric. It's ClO4 and HCl. HCl and HClO4. Yep,
Where is that on the back of the table?
it's not.
Oh, that's why we got it.
You gotta know it. I know it. Chloric and hydrochloric. So I brought no clean clothes.
I have to like.
it's
H2SO4. It's the first sulfuric. H10O3. Nitric. Not HNO2. That is a weak acid, because that's nitrous.
Oh, that's what I'm not gonna remember.
Bromic?
It's like what it actually is.
Bromic.
Bromic?
That would be HBr, hydrobromic. Hydrobromic. Hydroiodic.
So they're all gonna something because except for they're all gonna have it in H.
It's in the notes.
Okay.
It's in the notes. So I brought no clean close.
I got that.
Yeah.
And then basically just the first row minus H, right?
For what?
It's just like LIK,
OH. Yes. Alkali metal hydroxides. What else? What number, Derek?
I'm thinking like 170.
117. 117. 117. It's a high number, right? We don't know.
And then I had to redo it.
Okay. 117. Determine concentration of OH, H plus, and the pH of the following solutions. So on 117, I am given 1.0 molar KCl. So let's write our little dissociation equation. KCl yields K plus Cl minus. Agreed?
Yep.
So what is this?
Weak
This is weak,
base.
right? This is weak base, correct? So on this, what do they give me? It's 1 molar. So they give me 1 molar. So what am I going to do for an equation? Ideas on this?
Ice.
Is this when you add instead of H2O? We did something like that yesterday.
Well, I'm asking you guys what you guys did on 117 because I'm interested to hear your thought process on this. What? OH is equal to H. Why?
Because
True. They're the same. Why?
To get to the equal valence.
To get to equal valence. True. Guys, KCl. Is it an acid?
no.
Is it a base? It's neither. All right? KCl is neither. KCl is just an ionic compound. Agreed?
Yeah.
Therefore, what is my pH going to be? 7. So don't overthink that.
Because it's not.
All right? Right. There's no donating available here, right? I have no H plus, I have no OH in it, right? That's just an ionic compound. So for this one on letter A, right? pH equals 7, right?
Yes.
Which means my concentration of OH has to equal 1 times 10 to the negative 7th molar, right? Which means my concentration of H plus, right? You were saying it, but I just wanted to say why, right? H plus is also 1 times 10 to the negative 7th for 117. A. 117B, all right, is a little bit different, right? Because if I go to 117B, I have K C2H3O2. That's going to break up into K plus C2H3O2 minus. Agreed?
There have been H2O, you just didn't write it, right?
Yeah, there's water there, but we don't care about the water. And we know that C2H3O2 minus is a what? That's a base, right? That's a base. So for this one, I can actually write an ice equation. Yes? So I would write C2H3O2 minus, what am I adding to that? Water, right? Plus H2O gives me H, C2H3O2 plus OH minus question.
So how do do you know it's a base, cause like, or just not a compound?
This,
Cause it's not a strong base.
it's a weak base.
Yeah.
Because I would think about, well, first of all, we've seen this tons of times, right? Acetic acid, right? This is probably the most common weak base that you get. That is one of your most, and think about it, like it's a conjugate, right? So I would think of like, is there a conjugate to that, right? The conjugate of this would be HC2H3O2. So think about it as your conjugate acid-base pairs. Is it possible, right? Is it possible? So that's what I would think of it in terms of conjugates. Are you guys okay with conjugates? Okay. Okay. So on this one, we're still on 117, right? I'm starting out with 1 molar of KC2H3O2, right? So my I is 1.0 molar. Not part of it, 0, 0. Change is minus X, not part of it, plus X, plus X. E, am I still on the screen? E is going to be 1 minus X, not part of it, X and X. On this one, do I have a KB or KA? No. You're going to, what's that? You're going to have to look it up, all right? Which KB, I'll just give it to you. KB on this, yeah, you will not have to look up anything on the test. It'll be obvious.
I was listening to this when they said like you were gonna give them a sheet, I think. Is it a different test?
That's probably a different test. I think you're thinking of something else. You won't need a sheet on this one. Everything you need will be on every problem. Okay. Why are people tickling? This is getting weird.
Trying to take his sweatshirt off without taking his sweatshirt off.
5.6. It's very distracting. Times 10 to the negative 10th equals x squared over 1, right?
Oh, it's 1.0.
Because it's 1.
I feel like it's always.
So I had to take the square root of 5.6 times 10 to the negative 10th. And when I did that, I got 2.4 times 10 to the negative 5th. So that gave me 2.4 times 10 to the negative 5th, which is equal to concentration of OH, right? So I have to take a P. So the negative log of, you guys are going to remember it, I'm just telling you, of 2.4 times 10 to the negative 5th. I got from that POH equals 4.62. But I don't want POH, I want my pH, of course. So pH equals 13.38. No, 9. Sorry, 9.38. I was doing the wrong math. Yeah. Yes.
Where did you get the K?
Yeah, I had to look that up in the book. You're not going to do that on the test tomorrow. Thursday. You'll have whatever you need. Yeah.
Wait,
You
so
had to look that up. Yes.
you're saying KA times KB equals KW.
Yes.
So KW is always that.
Yeah.
So why is it 1?
Why is what 1?
Like which one's which in that equation? Like what's the 5.6 times 10?
I just looked this up. I just looked it up in the back of the book.
What's the x squared?
That's from the ice.
This is my K expression, right?
That's KA.
This is KB equals x squared products divided by reactants, the 1. It's just 1.
Oh, I was thinking it was like the KB equals KW over KA equation. Okay, that
No. On this one, you have to be given one of them, right? And you did not have KB or KA. You know what KW is. I didn't give it either. So, yeah. Joe.
On the test, like our secrets not gonna be like that, because like are we gonna always have like we're always gonna have 3 secrets for pH and pH.
It'll be obvious when you have to do sig digs. On the actual AP Chem test, have I told you this?
Well, we don't really know.
You haven't told us.
You haven't told us
I
that.
haven't told you about sig digs on the AP test. On the AP test, on the FRQs, so if the FRQs are out of like 50 points, 1 point is for sig digs.
Only 1?
But you don't know which one. And why would you want to miss that point? So guess what? Do sig digs.
1 point on each question?
No.
What would tell you?
1 point out of all the FRQs is for sig digs.
Just on one question, I get that.
What?
Do you do sig digs like throughout the problem or just on the problem?
I always just round at the end. Because you don't want to round multiple times, because your number's going to get less precise.
But how do you know how many sig digs you should have at the end?
Whatever you start with is what you end with.
Whatever you start with.
Correct. Yes.
For our test, are we gonna be doing something like this? Like where you give us the KB and we have to calculate,
Like
the
Or we have
pH?
fun like KA with KB or something
Yeah.
like that.
like where there's a KA or a KW. I mean, I would make it obvious if you had to do that. Yeah. Yes.
So if you were doing sig digs, you would only round at the pH and make it 9.4?
So if we were doing sig digs on this, on 117, they gave me 1.0, right? So this would technically be 9.4. But that's not great for pH. Like, I'd rather just have 2 after the decimal. So if it's going to be a sig dig problem, it's probably going to be something more mathy, more straight math. Just like boom to boom. Yeah. 5 big booms.
Oh my gosh.
I don't know what that means.
Mother died last week. That gets 5 big booms.
Oh.
I was wondering. They're like reacting to comments.
Yeah, I don't know what 5 big booms is, but I know it's a thing.
I don't even really know it.
Derek, why do you always have that?
Because he loves it. It's a stress relief bottle.
No, I said
Oh,
you
you
should
don't
take
get
it.
it. He was on
I don't
June.
want it. You should take
Panther
that
dressed
one.
in black.
137.
What's that?
I just want to know like what like happened, because I don't know.
137. Oh, that's a good one to do. Lewis acid, Lewis base. You've got to be able to identify
Okay, I was confused.
these. Okay? So for 137, let's redefine what these are. A Lewis base is what? Confusing. It's an electron pair donor. And a Lewis acid is an electron pair acceptor. So you've got to know what those things are. So if I go to letter A on 137, let's look at BOH3, right? Because if I can do BOH3, I'll be able to figure out everything else. So BOH3 is on one side, and I've got BOH4 minus on the other side. So what did BOH3 do?
No, it accepted on the other side.
BOH3 became BOH4 minus. So how did it become a minus on the other side? So BOH3 is a what? Lewis acid. It's Lewis acid. What was my base in this situation? Water. H2O was my Lewis base.
So if you do one of them, like it's always going to be the reactant.
Is there other ones or is it just Lewis, or is there other types?
Bronsted-Lowry.
What's that?
Bronsted-Lowry is,
It's not gonna be like.
I'm like glitching right now. Yes.
I must have mixed.
What's that? I think Bronsted-Lowry is like your more classic.
Oh, I do.
Somebody look that up. Bronsted-Lowry is more about the proton donor, right?
Any species that can donate a protein.
Yes, Bronsted-Lowry is the proton donor.
So is that?
Well, that would be the acid, and then a base is any species that can accept it.
Right.
So that's just what we've been doing.
What I'm going to have, what's that?
That's what we've been doing.
It is what we've been doing. So, what there could be on the test tomorrow is I will say, label this as a, not tomorrow, sorry. I could say label this as a Bronsted-Lowry base, a Bronsted-Lowry acid, or one of the two. I'm probably not going to have you do all 4, right?
Oh, no.
Okay?
I think that makes.
So it'll say, label it as a BLB or a BLA, or label it as an LA or an LB.
So the Brunson Lowry one will be, it's like positive. Is this one thing? Okay.
Yes.
Okay, what?
Yes.
Can you
I just said
explain
that. What should we
the
do?
Bronson one?
Bronson Lowry is what you think of like as a typical, right? Bronson Lowry, whatever's donating the proton is the acid, right?
Okay.
Whatever's accepting the proton is the base. This is talking about the specific electron pair.
Okay.
So that's just a different way of saying it. Next one on 137 is I've got Ag and I've got NH3. So on this one, this is weird. Okay? So, first of all, what do you guys think? I will give you a hint. I flew. What'd you say, Will? Or were you having your own conversation? That's fine if you are. I've got Ag plus and I have NH3. Those are the two things. Now I have to decide which one is the base and which one's the acid. Yes?
Isn't Ag the acid because like when it's not like two NH like together, it's minus? Like and it has like an extra electron pair?
Ag is the acid. All right? Ag is the acid because on this one it's the electron pair acceptor. All right? Why is it going to accept an electron? Well, it's a plus charge, right? If it's a plus charge, it means it's done what with one electron? It's short an electron. So it wants to accept it. Yes. That's what you got to think about. What's that? So this is going to be your Lewis base. So on C, I have BF3, right? So BF3, is that my acid or my base? That's my acid. You guys got it. And then that means my F minus is my base. Once you talk through that, it makes more sense. It just helps to talk through it. And it was in the notes, but we never did an example.
So you just say what the acid base is.
Yes. Which is the Lewis acid and which is the Lewis base. Or which one is the Bronson-Lowry acid or the Bronson-Lowry base. But yes.
I think it's more
But yes.
That's the rot of the iron, right?
What?
No.
No.
H3.
This is not. The B is bromic.
So would the Bronson Lowry be the opposite of what you said?
Yes.
Okay. So if I know that it's the Lewis acid, I know it's the Bronson Lowry base.
Correct.
That makes sense.
Yes. Okay. Anything else? Audrey.
Are we gonna need to know the R minus bases and acids?
R Highness?
I think that's how you say it. A-R-R.
Oh, Arrhenius.
I was close.
I was like, is this a new acronym I don't know?
R minus.
No.
R minus.
No. And there's even an Arrhenius equation. You guys don't have to worry about that'll be next chapter, but that's actually not part of the AP curriculum.
So you're just very sarcastic.
Good question.
Can we do 109?
143, and then we'll do 109. Okay.
So they would talk about this on the practice test, why
143. A 10 milliliter sample of HCl has a pH of 2. What volume of water must be added to get it to a pH of 4? So this is 143. See what's on the book. Okay, so let's talk about it. So we know at pH 2, right? Concentration of H plus has to be 10 to the negative what? We're just talking logic here. 10 to the negative 2, right? Which would be equal to 1.00 times 10 to the negative second molar.
Yes.
Right?
Yeah.
At pH 4, my concentration of H plus would have to be 10 to the negative 4, which would be equal to 1.00 times 10 to the negative fourth molar. I also know that my moles of H plus present is going to be equal to, on 143, I have how many liters? 0.01 liters, right? Time on this, for every 1 liter, I have what molarity? How many moles? It would be 0.01 moles, right? Yes, that's what you said, just in scientific notation. Because on 143, they said, why am I saying 0.01 moles here? Why am I saying 0.01?
That's how.
Right, that's the concentration, yes?
Yeah, so for every liter you have.
So this is 1 times 10 to the negative 4th molar. So now is where you've got to do like your assume something, right? So let's say let V, quotations, okay? Let V equal the total volume at pH of 4. Are you guys with me so far? We know that 1.00 times 10 to the negative 4th molar has to equal something, yes, has to equal something over V. And what is that something? Well, it still has to be 1.00 times 10 to the negative 4th. Why? Why is it the same? It's 1. That's the concentration. It's 1 to 1. Yes. So what does V equal? 1. So V equals 1.00 liters. That's not the question, though. The question is the volume of H2O added. So it's going to be 1.00 liters minus 0.01 liters, which gives you 0.99 liters.
Is it fine if I did it in liters?
Sure. That's great.
Live life on the edge.
I love it.
Yup. Life on the edge.
Lucy, did you want 109?
Yes.
Okay. 109.
We really are going around.
109. 109. Calculate the pH. Okay. So is the baseball field going to get done?
It's supposed to take 3 weeks.
Okay.
And they can do it.
What do you mean by whatever they can do it?
They have to wait for the ground to be like dry, so they can grade it so it's flat and put down the drainage.
Yikes. It's supposed to rain all the rest of this week.
Yeah. But it looks dry out right now, so they might be able to do it.
Okay.
But then they're not.
One day.
Live in the moment.
Well, once they do that, then like they can put down drainage and get it done.
I'm trying to believe for you. I'm trying. 109.
He's stressed. Look at, yes.
Me?
No.
Derek?
Derek, we need to let Derek take it.
He needs the bottle.
I
All right.
He always.
The
He does have to be always, and I think it's always that way.
clarifying context. When I say the bottle, I mean an experimental bottle of acetone, water, and salt. What? Well, I'm just saying, when I say he needs the bottle out of context, that could sound bad. So, well, like the bottle could sound like alcohol. So, that's the bottle we're talking about. Okay. 109. 109. Hardest thing is probably writing your R, right? On 109, I have H2S. It's going to be in equilibrium with what?
H plus HS.
H plus what? HS minus. HS minus. Because we know that we have to get some kind of H or OH, correct? So I got to get H by itself. When you are attacking one of these, be thinking, I need to get H plus, I need to get OH minus. How can I get it? Okay? And that's how I can get it. I, on 109, is 0.1 molar, right? So 0.10 molar. Am I going to have anything here to start? 0, 0. Change is minus x, e, 0.1 minus x, and x. On 109, what do they tell me? They tell me that I've got a Ka, right? So I'm going to use my Ka1, which is what? 1 times 10 to the negative 7th. So Ka equals 1 times 10 to the negative 7th equals x squared over 0.1. You guys okay with that? Yeah. So my first x, soon. My first x equals 1.0 times 10 to the negative 4th. So that's my first x, which is this. Yes? Now I've got to erase it again. So RICE, right? So now I'm going to start out with my HS minus, which is going to give me, because I have to do that, because what are they asking for on 109? They're asking for the concentration of S2 minus, right? So that gives me H plus S2 minus. So you got to double erase it. You got to double erase it. So now here's my x, right? Which is going to be, this is a little bit weird, 1 times 10, yes. I've got 1 times 10 to the negative 4th, but I also have 1 times 10 to the negative 4th, because that's x for both of those. Agreed? Yes. And 0. Change. Minus x plus x, e, 1 times 10 to the negative 4th minus x, 1 times 10 to the negative 4th plus x, and x. And then they gave me Ka2, right? So Ka2 is 1 times 10 to the negative 19th, which equals, this is going to be messy, right?
But since it's so small.
Here's the thing. So it's not that messy. So it gives me 1 times 10 to the negative 4th, right? Plus x, yes, times x, over 1 times 10 to the negative 4th minus x. Where are both of these x's going to go? 0, 0. That divided by that is 1. So this equals, yes. So 1 times 10 to the negative 19th equals x, which is equal to my S2, which I was going for. So that equals x, which equals the concentration of S2 minus. Yeah, we are. Oh, the pH? Well, the pH, I would just take the negative log. Yeah. You guys know how to get the pH. So that was why you had 2 Kas. Tomorrow, yes. Because up here, I had x, right? I have x and x. Both of those x's are equal to this. X is h, right? X is also hs. So those are equal. That's for both x's. You okay with that? Okay. Guys,